Hola, ¿qué tal? Regresamos al programa por primera vez en México y América Latina. Para mí es un placer presentar a Dimitri Mikhalchuk de TESLASUIT para que nos platique sobre un producto increíble que queremos traer a Latinoamérica para aprovechar todas las bondades de las tecnologías inmersivas. Dimitri, por favor. Welcome.
Good day to everyone.
Welcome. Thank you for taking this call.
Yeah, thank you very much. Thanks for having me. I'm very happy, very glad to join the VRFest today. So let's talk about inventions.
Yeah, let's do it. Let me go ahead with the slides, if you don't mind. We can start passing along, and you share with us your input.
So as it has been mentioned before, I'm from TESLASUIT. My name is Dimitri Mikhalchuk, and I cover the Chief Revenue Officer position. So meaning I cover the marketing, sales, and business development on the side, and I'm one of the co-founders of the TESLASUIT. Today, the TESLASUIT is a multi-product company. Two of the products, which is Tesla Glove, you can see in a picture right in the middle, and the TESLASUIT, which is on the right. A very nice girl is wearing it. And let me tell you a little bit about it. So nowadays,
so this part we edit, no? And we carry on.
We can carry on. The TESLASUIT had started in 2016, and we've established our office in UK, in London. And from then on, we started the development of the next incredible technology that we wanted to be available for gamers initially. And we all thought that, we all believed that new wave of VR that has been restarted by Facebook, by acquiring the Oculus, would be all about entertainment. So the initial TESLASUIT development, it was the suit. We were concentrating on how to immerse the body inside the VR so the user could feel the rest of the digital worlds. We were only about 15 guys team, very small, very lean, and so this is the idea we took forward. Now in 2016, we first presented the Mobile World sensations across the 4G and 5G networks. So the idea was to demonstrate how not only we can work on a local basis, but we can network people across the internet as well. Later on in 2018, we've presented and launched our first development kit for sale at a Consumer Electronics Show in Las Vegas, USA. And from that point, we started gathering the accolades. And in January 2019, we won the Innovation Awards from CES. We started demonstrating better products, like more improvements. And somewhere between the 2018 and 2019, we took a pivot quite early into the enterprise and B2B markets. We saw that the gaming market is not catching up fast enough for us. And for what the wow effect the VR had already, there was very little room for haptic suits, even though the user would probably love it. There wasn't such a need, and there weren't that many integrations. So that was very difficult to sell on the market. That wasn't ready for it. So, but once we switched to B2B, we started heavily introducing the advantages, the many qualities that the suit possessed. And on top of that, we were counting on a higher level kind of feedback from engineers who would be using it, because we would be talking the same language. So it would be easier for us to understand how the TESLASUIT needs to evolve to become the best product ever. So, and once we moved on in January 2019, we also won the Best Unicorn Award in Europe. We were the fastest growing British startup at the time. And then we picked up the Best of the Best Product of the Year award, which was a rarity. And now it's like we're in a Hall of Fame next to Ferrari and iPhone and stuff like that, which would make us so proud. This was the moment. From that point, we started branching out. We were thinking that we need to come up with something that will make us not just one product kind of story, but we wanted to be to build something more fundamental. And at the same time, we already had ideas about the medical world. And so this is where we lay the foundation for the Tesla glove itself, plus the TESLASUIT Medical Edition. And to date, we're working on those in those directions. And I can now say openly that we've signed up with HSS, Whole Special Surgery, which is #1 worldwide for rehabilitation and hip replacement and mobility rehabilitation, things like that. Today, we probably are collaborating with more than 40 universities, so from MIT and Stanford all the way to Far Eastern Russian University on so many different levels. It's studies about human biomechanics. It's the studies about, for example, behavioral patterns inside the self-driving cars. Things like, so we open a myriad of possibilities to go into and conduct a profound research on the body, on an interaction, because we can open the channel of communication between the digital world and the human body. So anything that needs to be understood about the body, so the basics like mechanics of the motion, the biometry, the stress, we can read it, but at the same time, we can induce the stress, we can induce the cognitive load. So what would the person, we can answer questions, what would the person would do if the person is actually stressed or scared, like things like that. So we need to find the way to safely induce that kind of stress or distraction and then read it. That's what the TESLASUIT does best. And we've also launched the Tesla Glove, which is another beast of a product. To be honest, it has so many different features. It's the first glove out there. First of all, even though we call it a glove, it's actually an exoskeleton. So the exoskeleton is there to provide the feature that we call force feedback. So it actively moves the hand and stops the hand. So we can feel and touch the virtual object, and we can feel its flexibility inside the virtual world, which is a feature by itself. Where we allow to touch the texture as well. We have haptic sensations for the fingertips. So whenever we touch the surface, we can immediately feel that we're there. And we're solving the biggest problem of VR, where I know that many headsets now track the hand, but once you want to touch the surface, the texture, you can't. You will fall through because you have no mechanism that will stop you from that, or will make your brain understand that you've connected with the object. And that's what we're filling this gap quite successfully by providing this glove. So if we flip forward, I'll tell you about some interesting cases that we've built together with various companies.
Siguiente, por favor. Yeah, I mean, closer to the Ready Player One phenomenon.
Yeah,
right?
yeah, yes. That's the whole idea, and we surpassed what the Ready Player One was showing was just haptics and motion capture. We've surpassed it by listening to the body, by actually having biometrics built in. We're now toying with heat. Virtual heat, which can be induced actually physically, so people can feel the source inside the VR, which is another channel of haptics actually. Our body is tuned to feel different types of heat. And today the TESLASUIT systems comprise of haptical systems, so over 80 channels throughout the entire body. We're working on next gen suit, which is going to be 200 channels on, throughout the entire body. This is probably the most precise system that can address different parts with different levels of haptical feedback. And we're delivering EMS and TENS, which has a direct medical and rehabilitational application. We are looking at a motion capture. So motion capture is now set to the point where we're looking at non-VR applications as well. So motion capture can live on its own. It can gather enough information about movement, about posture, and so on and so on. There are many different medical applications where we look at now functional electrostimulation, for example. This carries a good, very profound rehabilitational functionality. So all these things have become possible now with TESLASUIT. With inertial sensors, we were fully untethered, so the product is fully standalone. It's literally put the suit, it's made in the form of a normal sports suit. You can see it's very easy to do the maintenance on. So put the suit on, zip up, connect the battery, it's on. And it takes literally seconds to connect it to VR. Very small calibration is required. There are two types of calibration. So we have the calibration for motion capture. That's 4 seconds and it's done. And we're still thinking that's too long. We're going to sort it out that there's no calibration required for that. And for the haptics, we do need the calibration because our haptics is as strong as the human body itself of the user. So we want to put the threshold of the maximum and the minimum that the user wants to experience. So from time to time, from day to day, we can feel it differently. We can be more ticklish in the mornings, like after we've eaten something that makes us very susceptible to that. So very small calibration, tweak calibration is needed. And usually from the first time use, it's 3 minutes to like 15 minutes to set it up nicely to the specific user's body. And then the profile is saved. So you don't need to recalibrate every time. You can just carry on using, providing it's the same user. Where it's a multi-user environment, we recommend to load the profile, and that's it. It's just a name against the preset, and it's all done. When we look at the biometry, we measure heart rate and heart variability, ECG, and the electrodermal activity. So the EDA measures the resistance of the skin, and it can tell us about the stress levels in the body, so how the person has been reacting to specific visual and oral stimulation. We can look at how a person is tired. So we can take so many different measurements. There are 5 different dimensions, and EDA opens up access to 80 more different types of measurements that we can collect on the body. All that is ultra important for understanding what the person goes through inside the experience itself, and to build up, to help the environment itself to adjust to the user. So, and this is what we're also promoting, and this is where VR is moving actually. It's a multi-threaded scenarios. So imagine if the environment itself knew what we're feeding, knew how we react to specific things, and if it could adjust the scenario itself to what we want, rather than a flat scenario for everyone, and maybe some people don't get it at all, and they get lost or get bored. There's nothing worse than that for both sides, like the user, the consumer, and the developer, because the developer wants people to engage. The people want to engage as well as consumers. So hopefully we'll provide enough toolkit for developers to dive into this and utilize our functionality to make the content better and dynamic. Some of the use cases include very high profile development, and we're working with a large number of aircraft manufacturers nowadays, and a lot of training facilities for in-flight simulation. This is one of the very popular topics because it's very expensive to train, and if somebody misses even one maneuver, that usually means sometimes up to like $7,000 an hour gone. They need to retrain, and that's just one airplane. Usually they need to have, when airplanes need to fly in tandem, that's 3 airplanes or 2 airplanes with a coach in another airplane. And if the trainee misses the maneuver, it's $7,000 per plane. So all 3, that's $21,000 an hour wasted. So what we developed is a much cheaper training solution where the TESLASUIT provides the similar kind of cognitive and physical load on the body. It stresses the body similarly to the maneuvers themselves. And so it is possible to train on a static platform in a gym, for example, or in the room where it's set up, and it helps reducing the cost. It helps focusing better, understanding how the maneuvers are actually happening, and then start anticipating the maneuver, because on the plane we're moving so fast, we need to think ahead. And then the bigger the plane, the faster it goes, especially in the jet fighters, for example. It gets so complicated, they need to read ahead like 5 steps, 7 steps, 8 steps in advance. So that's a challenge, and we're helping solving that as well. In fact, our first customer was NASA, and we sold our first suits to the Advanced Human Performance Labs in order to build the multi-factor training facility, which they were working on, which would train both physical, cognitive, and mental capabilities all at the same time, wrapped into VR, plus the physical machine that would turn people around. We know that in space, there are different challenges. So not only gravity can be zero, it can be double or triple. So when the rocket is actually leaving the Earth, we have to work under stress. And that stress of high gravity is as bad as the low gravity, because in the low gravity, our blood circulation is messed up, and our brain doesn't function the same way. So everybody, even though they're floating in the air, everything, the decision making is actually done under duress. The brain is under stress. The brain doesn't understand why there's no gravity pull. I need to fix it. I need to help the body to get out of it. So the brain is constantly stressed out in space, and that's what we try to accomplish. We try to prepare the human body for that, for those conditions, difficult conditions. So we we tweak the conditions to be similar to both in space or on the moon, for example, microgravity, lower gravities like Mars conditions. We're looking at Mars 2030. We're looking at moon-based construction projects nowadays. There are a lot of conversations within NASA, and we're opening new streams. The Tesla glove is being sent to NASA as well. So there are many, many different angles of collaboration within space industry itself. In fact, I hope we have the we participated in another project which is led by the French-Canadian company called Stardust Technologies, and this time it's sponsored by the European Space Agency, and we're building the solution which can be taken on board of the spacecraft and used for long-term space travel. Now, the biggest challenge, for example, for Mars landing is that there is a 49-minute window, I think, like black window, where there's no comms. Space agencies want to know what happened during that period to a second, to a T, basically understanding what the body was going through, how the landing can fire up, or if the mission had failed. We need to have that information so we don't make the same mistake over again. Plus the psychological state. The project itself is focusing heavily on how the astronauts can engage in an analytical part, and at the same time, how can we influence the psyche of the astronauts so they're flying safe. Imagine being sat in a can that travels far, far away from Earth, and potentially you're realizing this is a one-way ticket. There's no guarantee it will land safely, which Elon Musk had confirmed. He said, if I knew it would land safely, I'd be the first one to go to Mars, but I'm not. So nobody knows it will land safely. And through that period, whilst you're traveling for like 8 to 9 months, you're on your own. You have to talk to yourself. You're on your own. You have to manage your psyche, and it's difficult. It's hard. Like many of the training missions on Earth to simulate Mars leaving and stuff, they failed. People thought it's easy to be locked up in a small room, but it's not. And eventually, because human is a social being, it catches up with us. So managing that, providing enough conditions, visual stimulation, oral stimulation, physical stimulation, the sensations of a hug, smaller things that we don't that we actually take for granted, but they are ultra important. Like hugs actually fire up so many synapses in our neural system that they actually stimulate the brain very well. So this is what we're working on, looking at different applications and trying to build a sustainable system that will help us to go through and actually explore the far space as well, beyond Mars, beyond missions that we already know of. So this is very interesting for us. We're also becoming a major player in what's called highly critical training. We participated in a number of proof of concepts across the globe for the industries where the cost of mistake is actually a life or an injury. And together with Schlumberger, this is one of the biggest oil and gas services supplier, we built a training. We have a video we're going to show you in a minute, where we train operators for a major failure. Now, in the oil and gas industry, the failures are happening on a daily basis. We just don't hear about them because they rarely make it to the news, as they're always remote, and usually people are good enough, well trained enough to complete it in a reasonable time. Sometimes the failures are so big that they are actually putting the entire business at risk of collapsing. And this is what we're looking for. They're called low frequency, high impact events, very expensive, very rare, and very hard to train for. The queue to get to low frequency, high impact events in gas industry, for example, is 12 months. And that's globally, imagine. And if you're sick on that day, that's another 12 months of waiting. And within the training, they need to burn something or explode something, which is an expense by itself as well. But the reason for that training is so that when people find themselves in a very stressful situation, they don't lock up. They know what to do. They know how to make themselves safe, their colleagues safe. They need to get out and shut down the critical points so the disaster doesn't become a global issue. And let's have a look at the video. Yeah, so in the video, we show how the operator, upon seeing the alarm, has to get out, shut down the pumping operation in a specific form. Usually the operator fails the first time, and we want that operator to actually feel the explosion and feel what it is like to be on a platform which is falling apart, because it teaches the important key lessons. A, there's responsibility, like the responsibility point. B, disaster. Everything is time critical and no time to lose. So they need to learn the procedure to the T, that they need to act, and that specific demo is only accomplishable within 24 seconds. Imagine you have no time to waste. So that's that. Also, we work with the companies, the energy sector, for example, where again, a risk of electrocution, a risk of running into heavy machinery is very high. And we built a training simulator which allows the electric companies to train the operators of the equipment within the power plants. Now, not only that improves the safety record because of the muscular memory, because of deeper, profound understanding. Once you break something, you usually understand better how it breaks, and so you know how not to break it. So that's what VR opens up. Now, previously, to break something, you had to physically pay for it. Now, in VR, we can break things as long as we want, and it doesn't cost us so much. Now, with haptics as well, and we've added a factor of what's called a subthreshold stimulation. The TESLASUIT is capable of stimulating the nerves at the level which is not felt. We don't understand that we're being stimulated, but the brain picks it up. On EEG, it actually will be seen. Now, we use that factor to actually give a little nudge in places where the person makes mistakes. So the person starts thinking, okay, I must have made a mistake. I can feel it. I know there's something else. And that changes the learning curve. So it improves the memory by 50%, memorizing of certain aspects, and it reduces the number of mistakes by around 30 to 50% as well on average. So that actually saves the power plants, the electric companies, a lot of money on bringing up the talent. Imagine the course itself. So to let the person, the electrician, work on his own on the power plant is 5 years after you graduated from electric course. So that's 5 years of paying salary, but the person cannot do work. He needs to be supervised, looked after, and he can only help with things, but not do things on his own. Now, if we reduce that time by 30%, imagine somebody can progress like a third faster. We're talking now from 5 years, we reduce it to 3 years, for instance. And the error rate drops down, and the better, profound, deeper understanding is up. So there are so many positive things that this method has been. The moment we proved it works, now DTEC, one of the biggest Ukrainian power plant operator, is deploying it across the 80,000 strong force across all of the power plants that they have, and they're actually creating an agency which is going to be an academy for other power suppliers in the region and in Europe. So soon we're going to see these training courses with what's called haptic assistance and a full like equipment presence inside the VR. And I hope it comes rather sooner than later, because it will save a lot of people from injuring themselves and actually make things better and reduce the cost, the running cost of things. So this is another case that we built with Volvo. Now, Volvo Cars has built what's called Ultimate Driving Simulator, where the car itself is connected to mixed reality. You see the Vario headset with the pass-through technology. So the driver and the passenger, they can see the real world, but at the same time, they can see the overlay of the virtual world. Now, the car believes that the virtual world is real. And at some point, the car is allowed to drive itself, being fully autonomous. And from that point, we train the AI to react to the traffic situations, which we generate procedurally inside the virtual world. So you will see the video later on, but having an animal in the road, or having somebody overtaking the car aggressively and then seeing what the car would do in that situation is no longer a matter of, modeling it in real life. We just throw virtual objects at it. And we study what the car does, but at the same time, we'll look back at people inside the car. And this is where TESLASUIT helps us accomplishing many things. Like we see the movement, the reaction, because the driver is no longer in control. He doesn't anticipate that maneuver. So what does he do? We need to understand that. Now, if the overtaking is too aggressive and if it's a dangerous situation, then the belts need to pretense. And we can study that now in a different shape and form, because we now understand better what people actually are doing inside the vehicle. So this opens up a myriad of different situations, and we can increase almost indefinitely the number of key points on which we collect data, so we can train better all the AIs that are responsible for our safety, that are responsible for our comfort, and are responsible for actually driving the car and making sure that we don't feel sick and we don't feel under duress as well. So we have a video to have a look at, which is quite nice, of a real car on the real road. So you can see a virtual animal there. We can actually skip it if you want. It's like a nice. Now, another project, another big area of our development is concerned with Tele Robotics. Now, there's been an X Prize, a competition in US, which had a $10 million prize for solving the problems of telesensing using a human body and a robotic bionic sensors. Now, this is where the TESLASUIT had participated as well. And NASA has had a competition on that. And now I think Elon Musk has given, I think, $100 million to that X Prize for the next stage development of different robotic equipment and things like that. So imagine how important this is. And the market itself is actually a $200 billion market. Now, places we use it is ranging from so many, from submersible underwater discoveries where we need to move the manipulator, we need to grab things and lift it, all the way to space again. If we wanted to manipulate something on the outside of the spacecraft without needing to get out, That's where we need the precise electronics, and we need to actually feel that we're gripping something. We need to feel the force, and that's where the Tesla glove comes in. We've started collaboration with Honda Research on that. This is where we're looking to both apply the suit. The suit itself allows us to feel, to basically impersonate the avatar of the robot, and then with VR we can actually see ourselves. But in fact, we're moving the robot, which is a representation of us, and through haptics we can feel that we've already touched the object, and then through force feedback we can feel how much we're gripping it by, and how gently can we remove it and then take it away. So imagine how many different things are opening up. We can do remote aircraft inspection, for instance. This is what we're looking with NASA now at. We are looking at disaster recovery, for example, sending the robot through the disaster and finding objects in the rubble and actually manipulating that rubble and things like that. So there are so many different things that we can do. And let me show you.
And the sizes, no, Dimitri? I mean, like suddenly, if the potential to operate, like we normally think of like massive robots, but also like nano dimensions are incredible, no?
Exactly. Yes, this can attach to any size robot, and going micro as well is interesting because imagine actually tracking the micro robot. It's impossible. It's too small. You can't see it. The moment it moves like 10 meters away, you can't even see the robot itself. Now, imagine if you have a replication of yourself in a scale, like in a scale. So if you need to move like a nano, like a few microns, you can move it in a big move on your hand, but it's a scaled movement inside there, and so you understand the correlation. And if it's in VR, you have the visual representation of what's actually happening. So you can dive into different worlds and you can see things much, much better. And our brain processes it much better as well. A big part of critical training is actually defense and government services. You know how first responders, they need to be trained like machines. They need to perform, they go on long shifts. Like I can't imagine myself doing what they do after like 24 hours waiting for this emergency call. And yet, 24 hours on, they still have to perform because we're expecting them to perform and save us. Firefighters, we're talking about police, we're talking about anti-terrorist units, for instance, and so on and so on. And this is where we bring many different applications and capabilities to the market, where we help reducing cost. Like every part of training, it actually costs a lot because of the expense on the equipment, expense on the fact that they need to board up a specific building, for example, to train on it, because they need to understand and remember how it is in real life. And on top of that, disasters are never the same. So on top of like building the memory and understanding of what's done on this particular building, first responders need to understand what to do generally in any situations which is unfamiliar. So they need to be the decision makers, the leaders themselves. Like every person within the team has to be a leader, and then they have to work with the leader on top, which is super hard. The things that we bring together now with using 5G technology, for example, we can mix and match virtual training with real training. We can have some people in the real field, some people in the virtual space, and they can collaborate as if they were in the same room. We can track the entire body's performance and record it, so later we can review it and actually say, look, in a team of 10, 2 of you, why were you going that way? You were supposed to be that way. 2 of you guys, you actually endangered yourself. Don't do this anymore. Like, make sure everybody understands what we're doing. Blah blah blah. So, previously recording such a footage, it was impossible. You need like a crew of like maybe more people than people training to be able to record from every angle. Yet the TESLASUIT allows us to build that same model as Matrix. If you remember the Trinity that was like flying and fighting with the police, imagine we can get that data of that specific body in any point of time, and then we can play it forward and backwards, and we can see what the person was actually doing in 3 dimensions. We can reconstruct it in VR, and then we can have the full like room scale experience, and we can understand how people were supposed to be positioned, what they were supposed to be doing, and then we can throw simulated situations like randomized disasters and things like that, where people can go over and over again and train and learn and understand how to act in any situations, which is unfamiliar, which is very ultra important. We're also generating stress, which is an ultra important part for any synthetic training, because I've been looking at different like industry days and how the police, for example, is training, and if they're facing like visual, like virtual reality gaming, they at some point they're actually taking it as gaming, because there's no real implications. I mean, you just laugh, you grab, you go Rambo style, and like you think nothing's going to happen. Now imagine doing this in a Tesla suit, which actually makes you feel that you've been shot, like real shot. You're not going to play with it, you're going to toy with it, you're going to take it seriously, because the moment you get a grazing bullet, for example, from a terrorist, that's it. You're back in the situation where you understand it's 100% dangerous. You don't save like in a game. You've only got one life. That's it. You have to be very careful about this, but you have to be fast. You have to be a leader who's charging, and at the same time making the right decisions at the same time. Recently, we've embarked on a mission to train the UK police for non-lethal weapons usage. UK police was probably the least armed police in the world. I think they never had guns. They never had. They only had buttons, maybe at the best. Now they're being issued with taser weapons because of the terrorist situation and so on escalating in Europe. So suddenly 30,000 people need to be trained in a shortest period of time, and this is where we provide a good platform for this. And TESLASUIT is capable of generating or helping generating different situations where the police is wearing the suits and that avatar is being represented inside of VR, and at the same time somebody else can impersonate the bad person. So there's actually people-on-people training, which allows us to run complex scenarios, like conversational. Police is there to diffuse the situation, not escalate it. So that's what everybody's being taught. And the police needs to like make things safer rather than escalate it to the point where we see total aggravation. And this is what we're happily embarking on. We want everything to end peacefully with the least amount of damage. And this is where we believe we can actually help both sides to understand how things can be diffused rather than escalated to the point. This is the industry day that we've participated in, and you can see we've also thrown in like a tactical weapons handling. For handling weapons can be challenging and dangerous, and the police doesn't always get access to the weapons, as I mentioned before. So it was important we show it in VR at least, so they can get accustomed to standard rules, standard procedures first, before they get introduced to real weaponry. We've collaborated with XR Tactics, the company from Norway, and we built a simulator for counterterrorism unit training, where the scenario is like a content management system. So there are multiple scenarios that can be preloaded on a day for that specific group to carry on training and working out. And we have a little video that shows how the operator is seeing the entire team working, and then the team itself, the first-person view, which shows how this scenario is progressing, and then we can have a full review of what was going on within the training. So next slide is actually the video. Yeah. This is our little demonstration of the Flashbang Training, and it's interesting how the person on the right actually feels the explosion inside the virtual reality, and the suit is so strong it can actually move the body, which is quite fun. So we can skip this one. Firefighter training, this is another big area for us, and we work with Rely New Tech and Indigo to build a simulator. And in the video that we have in a few seconds, we see how firefighters are moving through a very low visibility room. Their task is to find the body and bring the body back safely. Now, this TESLASUIT here is looking at the posture and the safety aspect of every firefighter trying to pull something heavy. So we train them to pull heavy objects safely as well, because if we lose the firefighter inside, we've just doubled the problem. We were looking for one body, now we need to look for multiple bodies. And this is very difficult to work in because not only they have to wear the coveralls, which is very hot, conditions, low visibility, no oxygen, it's very difficult to work. And on top of that, we just put one, like Easter egg, we call it, inside the simulation. They disturbed the pocket of air, which actually produced an explosion. You will see in a second what it means to be a firefighter in a real situation. This is the video. Nowadays, we're becoming bigger and bigger in sports and rehabilitation. And we're going to cover some of the interesting activations that we did before with TESLASUIT, and now adding Tesla Glove as well. Together with Formula One, we built a simulator for the visitors, VIP visitors in the paddock, and it was showing what the driver of the Formula One goes through when they accelerate, go through corners. And Formula One itself had provided us with telemetry from Lewis Hamilton, victorious lap, and the video, 360 video that we had from his car. So this is what we did. We combined the VR headset so they could see the Lewis Hamilton's vision, and we added what's called physical stimulation of the body to replicate that same G-forces. Now, whatever the people are doing in the video, it's the suit that makes them turn the wheel, like accelerate, decelerate, and things like that. So it's quite good fun. Have a look at the video in the next slide. Another activation that we did with Vodafone was launching the 5G network, and we had an interesting activation where we had a rugby player on stage, Juan de Jong, from WASP's team that is being sponsored by Vodafone, and we had a special tackling cylinder 100 miles away in another city, and we had kids tackling the cylinder and Juan de Jong actually feeling what they're doing. The trick was that we never told them that the last person is going to be the biggest guy in the team who's going to tackle the cylinder, and everybody was seeing the surprise reaction of his. And on the next slide, we have like the full setup. The cylinder itself had an accelerometer built in, so once it's pushed, that speed of push was being passed through 5G over the air to Juan de Jong in London Sky Garden. So let's have a look at the video, and you'll see how fun it was. Yeah. Another activation we did with England rugby team for World Rugby Tour and MasterCard, which was a similar kind of thing, but we allowed the normal people to experience the tackle. And then what we did, the trick was we never told that the same person from the actual rugby team would be standing in front of them, and they needed to tell who tackled them. It was whether it was a real person on the virtual reality simulation. So that's another video that you can have a look at, and then we can move on. The Tesla Glove, which I mentioned before. This is the exoskeletal glove, fully autonomous, runs on battery for up to 4 hours. And it has not only the force feedback aspect and a unique approach to it. We've managed to solve certain things that have been kind of in the air, but not solved yet. We provided what's called motion capture with a sub-millimeter precision on fingers in all full dimensions. So it is possible to read it almost like on a surgical level of precision. And we've added the biometry as well, biometrical sensors. So we can read stress from the hand as well and understand what the user of the glove is going through. It is intended for the initial use. It is intended to be used for dangerous objects, Tele Robotics, and things like that. So it's also important for us to understand how the user is actually feeling and what the user is going through, so we can input the safety measures into it as well. You can see the technologies. For the haptic feedback, we've used electrohaptics, similar technology that we use for TESLASUIT. And each fingertip receives like a 9-point haptic screen, which allows us to generate different types of sensations, all the way to different textures. Now, if the user was touching the surface and moving the fingers across, then they could feel different textures as well. We can simulate that in real life. So let's move forward. I already covered the technologies, and you can see how we've also used servo motors to provide the force feedback, which is like almost 2 pounds of pressure per finger. It is possible to actually feel solid objects. I've tried it. It actually is quite believable. Like when you try and squeeze like something that looks like a metal object, you feel like it's actually hard, where there is no object in real life. Many applications that have been found is in aircraft design, aircraft maintenance, and pilot training simulators. We help replicating the entire dashboard, so the tactile memory of switching the panel, of actually moving the throttle stick and things like that is becoming possible, and it brings the price of simulators much lower than it is now, and it trains the physical memory of how things are to be done. So people don't rely on their conscious self, but subconscious is actually capable of conducting things almost 30 times faster. So it makes it flying aircraft safer, much safer as well. Another industry on the next slide that is very interested in the gloves is the automotive industry. Now, for a number of years now, I think it's over 5 years, top car manufacturers have been using VR to design prototypes. Now, that has reduced the development time from 30 days to 24 hours. It saves the operational costs. It actually helps doing what's called ergonomics testing, like to reach the buttons, to replay the entire dashboard, to make it more usable for the driver and the passenger, like in real time. And for that, the gloves with haptic feedback are very, very important and very useful. On top of that, we accomplish half of the ergonomics testing during the design phase, because the designer itself can feel and reach and actually make a decision on changes from that point. On top of that, we're participating in a wider ergonomics testing with TESLASUIT and gloves combined, where ingress and egress kind of testing is done, where the user needs to get in the car, make sure he doesn't bump into seating, like it doesn't bump into like center console and things like that. So we're part of the many different cycles within the automotive industry, as well as training itself. And the last but not least is manufacturing. So in manufacturing, when we're moving to a high level of automation, the technology needs to be both tested quite frequently. The maintenance is still a factor there. So we're switching jobs now from manual work to actually inspection and maintenance of that robotic equipment. Plus, it is possible to use the VR now for engineering, like overall design. AutoCAD is now available inside VR, which makes things so much easier to design, so better understandable because it's fully visualized in 3 dimensions. And training is a big factor as well. It's always a thing, like upskilling the personnel is very important, and it makes it a lot cheaper as well. Our compatibility, you can see we've listed some of the major players on the market, but actually we're platform agnostic, and we make sure that our products work with any headset that hits the market and has any kind of volume on the market. These are the names that we're actually practically collaborating with and our partners. So looking at developing many new things and features in the future as well. Our software comes with every product. We supply free software for designing the sensations. We have an open API, so we provide developers an opportunity to connect our hardware to any legacy software, providing you have the access to the source code or any future development. and we give full control to the developer. So we don't store any data that is being collected within the software itself. We don't process it. It's all given to the developer or the owner of the product. So this is what makes it very flexible. We're compatible with all the major 3D engines, Unity, Unreal, CryEngine, Android, and VBS. And we're actually working on embedding our SDK inside the SDK of these engines as well. So the CryEngine has already a special edition of CryEngine where TESLASUIT is already embedded inside. We're now going through the certification with Unity and Unreal. So quite soon, there's not going to be a need even to download anything extra. You just get the engine and start developing for Tesla with TESLASUIT support. These are some of the partners and projects. You may see some familiar names, some new names, and we've covered quite a bit of different projects. I think I personally probably have communicated with more than 7,000 companies already, and the number keeps growing day by day, which is good fun. Some of the universities that we've participated, worked with, you can see, as I mentioned before, more than 40 universities, probably now more than 60 universities, because the days are flying so fast, and we're opening new opportunities. But yeah, we're developing solutions which are looking to solve problems of health, injuries, rehabilitation, product use, space travel, you name it. It's a universal toolkit that allows us to create, and it's up to the creator how it can be used. So at the next slide, these are I think our contacts, and thank you for listening. Hope it wasn't boring. I'm open to questions.
It's been wonderful. It's been wonderful, Dimitri. Well, first of all, like, you know, I'm a fan of your work since that Consumer Electronics Show in 2018. When I saw the display, I was like, wow, this is like, you know, really that integration in which finally or physicality can enter into the virtuality, and now the virtuality can you know, come back into the material. You mentioned underwater, right? And that's one of the biggest challenges that we have also today. The whole exploration of the ocean is you know, it's a UNESCO objective, Sustainable Development Goal objective. And of course, you know, my favorite topic with this matter, the space, no? Because, you know, like Latin America is also doing efforts to gain into the space industry, but to be able to produce space technology is super expensive, and to do the simulations is also super expensive. So I believe these kinds of technologies in emerging regions in Latin America, Africa, Southeast Asia can represent gap reduction of both learning and you know, the capacity that we have to enter to this new era of industries and new ways to create well-being, you know, through economics and through knowledge, basically. I have one very important question. What can we do in Latin America to encounter with TESLASUIT technology and pursue collaborations with it?
Well, one thing is that we ship worldwide, and we do have stock. So I know we had to overcome some of the challenges of actually silicon production going into like underproduction. You know, that Apple has said that they're going to produce less phones because of the problems, because of the COVID. Luckily, we've overcome that. And on top of that, we travel a lot. I mean, I've covered probably 150 conferences in 2019 alone. You know, like COVID stopped me, and I thought, is it really me? I'm not traveling. Like, how do I live this life now? For me, it was a transformation. Yeah. But now the world is opening up. Like as I mentioned before, 5 countries in 4 days. I'm already in places. So, and I will be over in the US I think end of November, beginning of December. I don't know. We could set up a gig maybe, and we could collaborate on that as well. But alternatively, it's nice to have a lab of sorts, like XR lab, that people could come in, try things, and exchange ideas. This is the model that we're looking at in Southeast Asia as well, where you know, we don't have as much disposable cash as in the US, for example, and we need to come up with clever ways of getting the hardware in so we all could explore it. Plus, I personally overseen quite a few hackathons that we've run in places. That's another possibility. So obviously figuring out how people can get access to the hardware so they can develop and hack it, we can solve it. I mean, there's nothing that we can't solve in the world. That's my philosophy. We just need to try. We need to try and we need to think hard. We'll find a solution for this. But yeah, the suits are available. You can go through our website, TESLASUIT.io, hit us on the forum. If you're prepared to get things on board and developing, like universities, University Lab can afford it for sure. We have a special program for universities where we run it at a discount as well. One other thing I can tell you, a secret, Cyber Monday is going to be a discounted day as well, because I'm preparing the campaign already. That's a top secret, don't tell anyone yet. So yeah, to the wider audience, obviously. So yeah, things are becoming more and more available. And that's why we collaborate with so many universities. We want students to have access to the top tech, to have the vision of the future today, because it is the young ones who will take things and technology to the next level. They will be the main users and consumers of that technology, and they will be building on top of that as well. I can't even imagine what else can be built. I mean, when PC came out, it was perceived as a replacement for a calculator. It wasn't perceived as something we can watch movies on, edit things, program things, and so on. And yet, look at it now. Like we have now phones, which are like a replacement for a computer. AR, which is a replacement, which is seen as a replacement for the phone itself. So you can see how technology progresses really, really fast.
Excellent, excellent. Super happy to hear that, and the openness. You know, it's important that the Latin American community understand that there is companies such as yourself, that you know, such as yours, that has that philosophy of inclusion. And you know, we are, you know, you are opening, as you said, a $200 billion industry just on making the TESLASUIT able to move and operate big robots. So I'm sure the future is bright, and there is very good signs, even with the COVID challenge, that you know, for Latin America, that we're just creating audiences, you know, that we're on that stage, right. And that was, you know, it was a major like hard stop for exhibition and distribution. But I think that allowed also everyone to bring a new approach, and I'm very happy to have you on the VRFest, and I'm sure we're going to carry on with this conversation. Thank you, Dimitri, and
excellent.
You know, I'll see you around.
Yeah. My pleasure.
Bye. Thank you.
Take care, guys.
Bueno, pues muchas gracias. Pasamos al siguiente bloque.